Hey students, the Desmos calculator is the default calculator on the SAT, and it's an extremely powerful calculator. It can help you get to the module 2 a lot easier and get through some of the hardest questions. Also, it helps you be way more efficient, way faster, and make less mistakes since you won't be having to write things by hand as much. I'm going to show you the things that I like to do for the SAT. Number 1, here are some basic shortcuts to use, and it will help you to be way faster on the calculator, and so you don't have to be using the number pad right here to be clicking on different things. You'll be able just to type it on your keyboard and see it immediately. So here's the one I use all the time. So if I put x squared on my calculator, I can either type it in here, or I could simply press X and then I'll press Shift, hold it, and then press 6, and it'll allow me to put an exponent. I can put whatever I want up there. Another one I like to use a lot is the square root one. I just have to type in SQRT and I'll get a square root. Similarly, I can also do a cube root by putting CBRT. Or if you want to type in any root at all, you can just type in NTH for nth and then root. And this will allow you to put any single root. So I can put in 1, 2, 3, 5, 10. It doesn't matter. I can pick whatever I want. I can type in pi and I'll get pi. That'll come in handy every once in a while, especially when you're doing your geometry questions. So if I want to use my trig functions like sine, cosine, tangent, I'll just need to type it like here. I can put sine x, cosine x, tan x. So for example, if I do sine 30, then I'll see this value here. Now, one thing to note is you can always change your calculator from degrees to radians. So right now, I believe it's in radians. So if I want to change it to degrees, I just press this icon here, the graph settings icon, and then I'm going to press degrees, and now I'm in degree mode. What you might have noticed is as this little button came up, what that button does is allows my decimals to be turned into fractions. So I can go between just like this. Very useful. Two other functions that come in handy is mean and median. So if I want to find the mean of 3 numbers, I can just type them in like this. I can see the mean is the average, which is just going to be 2 for this number set. Or if I want to find the median, I can actually type in median, and then same thing, I put my parentheses and I just put my numbers as a list separated by commas. Once you get good at typing on the keyboard and using those different functions, you'll be able to get through the SAT way quicker. Now let me show you actual practice problems and how you'll use them. First, we're going to start out with questions that I think you can actually just plug into Desmos and find the answer visually. Let's look at these two here. I have on top, I have a functions question, and on bottom, I have a single variable question. Now, the trick for these is simply just to put it into Desmos and take a look. Now, when do I know when to use Desmos though? I like to use Desmos when I see that the function is very straightforward. It could just be some numbers with x, just like over here. Once it has more tricky things, such as like constants, you'll need to do just some small adjustments, but I'll show you those in a bit. So again, we have a nice straightforward equation here. They're looking for something like an intercept. Over here, they're looking for a solution. Of course, intercepts are just where they cross the axes, but solutions are where they hit either the x-axis, or if it's 2 lines, then it's where they cross or intersect. I'm going to put the first question in. So I put in 4x plus 28. If I just have like a y equals or h of x equals, I can actually just write the right side and it will understand me. So for example, if I was to zoom out just a little bit more, I see this is just a line. If you notice, if I were to put y equals, it would be the same thing. If I was to put h of x equals, it would be the same thing. They each have a slightly unique like Desmos trick associated with them, but we'll talk about that later. So here we have h of x equals 4x plus 28, and they're wondering what is the x-intercept and the y-intercept, and then what is the value of a plus b. So I can just take a peek at this one, and I see, okay, looks like the x-intercept is -7 and the y-intercept is 28. If I were to add these two together, well, guess what? That would just be 21. So let's go ahead and pick that answer. Awesome. And this is the correct answer. Let's look at this situation though. Here we don't have y equals. If you think about this, this doesn't have y because y is being set equal to 0. Or we have two equations that are set equal to each other. Well, when we have this situation, we have a unique thing that happens on Desmos. It doesn't show us a nice graph like a parabola or line. What it's going to do, it's going to show us using vertical lines where x equals 0, or what makes this function equal 0. So let's just go ahead and type in the entire function. So take a look. Just like we mentioned, it's going to be two vertical lines. This is what makes this whole thing equal to 0. So looks like these 2 points are 7 and 2.6667. So the sum of the solutions is just going to be, if I add those two values together, which is just going to be 7 plus 2.666667. So that's our answer here. Here, I'm just looking at some other ways where I can use this. Again, if I'm looking for something like an intercept and I have a straightforward equation or function that just has -8 plus 2, just some numbers with x, I can put that into Desmos and I can usually see the answer visually. Same with the question looks like this. It doesn't really matter if it's absolute value, if it's squared, if it's exponential. If it only has an x value and some numbers, I can put it into Desmos. You will get some pretty straightforward statistics questions where you'll need to just put in mean or median. In this case, I look at my first question, I see it's looking for the median. And then I will just need to type in that list of numbers and it'll just pop out the median for me. All right, awesome. I get 79 in this case. If I was looking for the mean, I wouldn't type this all out again. So some questions, they might ask me to find the median and the mean and compare them. I can actually just type in mean and then I get it here. So I can see here that the median is 79 and the mean is 79.8888. In this case, the mean is clearly bigger. Okay, so this next thing comes in really handy, and I would recommend everyone should know the simple way of using regression using a table and clicking the regression button. So take a moment to read this question to yourself, and then let's get right into it. So I'm going to start by making a table here. I'm just going to put in the values that they give me. All right, awesome. My table looks like their table. What next? Well, I'm just going to press this button. It says linear regression, and it gives me an equation for it. Just don't get too excited now. This doesn't mean that this is the answer here. They tell us that h of x equals f of x minus 13. So what I need to do is I just need to subtract 13 from this. So my correct answer here would be 5x plus 20 minus 13, which is just going to be plus 7. There's going to be cases where I can't just press the button and it'll give me the regression I want. This is one of those cases. Let's just take a quick look. In the drop-down here, I see all the different regression options I have that are built into the calculator. So I can put a linear regression. Just note though, it has to be in this format, y equals mx plus b. A quadratic regression, it has to be in this format, ax squared plus bx plus c. I have, and so on and so on. There's these standard forms, and if you want to see them, you can just kind of peek out and take a look at what the form is here. So look, I have for cubic regressions, I have some value, like an a cubed, plus a b squared, plus a cx, plus some sort of constant. It doesn't have every single function here. In this case, they're giving me something like a hyperbola. I see there's a linear function on top that also has a y-intercept. And then on bottom, well, the bottom part is x plus 3. So it's going to create like a unique shape. Let me show you the shape that it would create. So this is the shape it's going to make if I plug in, I just kind of put in a random linear function over x minus 3, and I see this. This is a hyperbola. So if I look at the drop down here, I don't have anything that says hyperbola or a linear function over hyperbola. So what do? Well, I have to do something called making a custom regression. You'll even notice that at the bottom here, it even tells me, it says, make a custom regression model in a new line using tilde. That's a little squiggly line. It's called tilde. However, I'm going to keep my table because this is going to tell me my x values and my y1 values. When I do a regression, I'm functionally saying, hey, I'm going to use these cool points I put in here on the table, and I'm going to model them using an equation. This is the setup for using it. I do y1 tilde, and briefly pause here. You might be wondering, how did I get y1? Well, I just put a y, and then I just press 1. And then it'll automatically give me the subscript. I'm specifically using y1 because our table values are referencing y1, and these values here are x1. So again, I do y1 tilde. Next, I'm going to put my line on top, which is just going to be y equals mx plus b. I'm just going to put the mx plus b part with the x1, so it uses those x values. Next, on bottom, I'm just going to put what they give me. They said x plus 3. And of course, I use x sub 1. So next, what it does, again, it models it as well as it can. So if you take a look, this is a hyperbola that goes through the points that I gave it. The points are in green. I can sort of unselect them and deselect them here. So look, it gives me an awesome regression, which is just a modeled line that goes through the points that I put on my table. So you can see them in green here. I can select them and deselect them. It tells me my regression parameters. So it tells me those points that I put in that I didn't know, like M and B. It tells me that M is going to be 4 and B is going to be 36. So my answer here would just be 0, 36. That is my y-intercept. Next, let's look at moving around functions. This is really handy, especially if you look at this and you go, whoa, what is this showing me? How am I supposed to move this down 3? Let's take a look. First thing I'm going to do is I'm just going to simply define my function. I put f of x equals all of this. What that will do is that it'll allow me to actually change things or plug in values for x's by simply just putting in a number there. So it understands that f of x is all this, and so when I put in f of 3, it's just plugging in 3 for all the x's that are here. I'm just going to plug in f of x minus 3, and you'll notice that it shifts it down 3. It's a little hard to see unless I zoom in. I'm going to zoom in a bit here. And you can see the original function is in purple, and the new function is in blue. Next, I'm just looking for which table matches. So I can do this a few different ways, but just simple enough. I can, if I want to, I can plug them all into a table. Of course, you can just put them in individually, no problem with that. But I can also just put them in like this. I see f of x sub 1, which is these values, minus 3, is just going to give me negative 3, negative 3, negative 3. Next, I notice that this is the most common way that you'll probably use Desmos. If you have a systems of equations problem, you're just looking at more than one equation and seeing either where they intersect or what makes them not intersect. So take a look. For this question, I'm looking for a solution. A solution just means, where do they intersect? Same thing for this bottom one, but just so you know, Desmos is only understanding the XY plane when it comes to graphing. So if you say a 2a plus 8b for something like a systems of equation problem, just replace the a with an x, the b with a y, or whatever letters they give you, replace them just with x and y. Here's the first one. I see the intersection at 0.46154. They just want me to multiply that by 39. I get about 18. Here's the second one. I noticed that they intersect at negative 125. Looks like my value of b, which I put as y, is just 25. So not so bad. Systems of inequalities come up too, and a lot of people are scared of them, but don't worry. They're just as easy as system of equations. Just one extra step is usually needed. My solutions for a system of inequalities is just where they both overlap. So you see this big shaded region here? This is where both of those inequalities overlap. I know my missing point is just going to be x comma 53. I like to just quickly put them into a table and then I can see them all at once. I see that this point here, negative 9 comma 53, is going to be our answer. All right, so next is a hard question type that trips up a lot of people, but honestly, they're super easy once you know how to do them. But first, let's talk about just how to recognize these. So when do I need a slider? I tend to need a slider when I don't know one constant. If there's multiple constants you don't know, it's likely a different kind of question. But if you're just missing one constant, just use a slider. So for the top question here, I'm just looking for a time when there's no solution, which means there's no intersection. All right, awesome. So I have my two equations here, and you'll notice that they'll give me an option to add a slider. I'm just going to click add a slider for this unknown constant, and that allows me to select a value for this constant. And I can choose between them very dynamically here. What you might notice though is that no matter how much I move it up or down this length, it will not give me an area where they do not intersect. That's actually just a limitation of the standard range that they give you. So what you'll need to do is just change the range. I'm going to go from negative 20 to 20. And since they're looking for an integer value, I'm going to keep it in steps of 1, which would give me numbers like 19, 18, 8, 5, 7, and so on. So here I notice that they stop intersecting once the integer k is equal to 14. So there we go. That's my answer. Not so bad. The next question, I have a circle question, and same thing here. I have an equation here. They're telling me it touches these 2 points, and the radius is r squared. So here's what I'm going to do. I'm going to put in those points. I'm going to put in this equation, and I'm going to add a slider. This is how I add a point, and there's my second point. I can also use a table if I want to. No biggie. All right, so here's my equation, and I already added the slider. Take a look what happens. I can play around with the radius, and I see I get a radius of 5. That's the correct answer here. I know r is positive, so I'm not going to use like negative 5 here, which would also be a correct value technically. But now while we're on the subject of circle, let's go ahead and tackle the hard circle questions that you might see. What's nice about circle questions is that even though this doesn't look like a circle equation, at the very least, they'll tell me it's a circle. So all I'm going to do is I'm going to plug in the circle equation that they give me. And just a brief note, if you're wondering, why does my circle equation look like this and not something like this? Well, it's just the same thing, but they foiled it out. That's all they did. Okay, cool. Now I just define the radius of this. I see that the high point here is 3, and the low point here is -1. That must mean the diameter is 4, which would be the distance between those 2 points. So my radius is just half of the distance, so it's just going to be 2. Awesome. I have some extra questions here you can try, but I just want you to know that's pretty much everything you'll likely need to use Desmos for. There are other ways you can use Desmos, but for the most part, these are the quick ways of using it. And the other ways, I'd actually recommend doing it by hand. But if you want to learn how to do more, I'll cover lots of extras in one-on-one sessions, workshops, and further videos. All right, take care, everyone.